Yes, dear participants of this course on micro irrigation engineering, now we are starting lecture 14. So, I welcome you to this lecture on measurement of irrigation water. This is a very important component of when we apply irrigation water in the field. Irrespective of whatever method of irrigation we apply, we need to know accurate quantity of water that can be supplied to the field. So, its measurement is very important. Now, in this particular irrigation lecture, we will be dealing with measurement of irrigation water when we supply through open channel, measurement of irrigation water when the water is flowing through pipes. In case of measurement of water through open channel, it is mainly dealing with surface irrigation, but sometimes situation it happens we are getting water from a long distance and then bringing it to the source place where we store this water and then keep it and then use it by network of pipe through sprinkler irrigation system or drip irrigation system. So, measurement of irrigation water in open channel or measurement of irrigation water through closed conduit pipe, these are all important component of when we supply irrigation water through micro irrigation system or through open channel system in surface irrigation. Now, why irrigation water measurement is important? Why should we measure this water? We know water is most valuable natural resource, and when we apply this water in agriculture, it is a life of any living system or agricultural plant system. So, its accurate measurement will be used for more intelligent way of applying irrigation water, and measurement reduces the losses which takes place during conveyance system, losses which it takes place in the field. So, this is very important, and so water to be distributed among the users or in the field, this is a important component. Now, this water can be at rest position, means it can be in a reservoir, it can be in a pond or it can be any container. So, we say water is in rest condition. Now, say when we are interested, we know this is the total volume of water it will be needed for the whole crop season or daily water supply system. So, we bring water from a long distance and store it in a reservoir, store it in a pond or we store in a some storage tank. So, in that case water is when it is brought and kept in a pond, we are interested to know that what is the volume of what is the capacity of the tank, what is the capacity of a particular, or sometime we need to know if it is water is to be supplied in a given system, irrigation system. So, we know that how much amount of water it is available when it is in at the rest, or it is in the motion, means when water is in flowing condition. So, this flowing condition it could be in an open channel, it could be in closed conduit or in a pipeline system. Now, for any when water it is in rest condition, means it is in a stored condition. When water is in moving condition, in motion, it has got some, it needs to be expressed in a particular units. So, if you say water is to be means given in a volumetric unit, so liter or cubic meter, it could, or when we are giving water in hectare centimeter, hectare meter, these are all volumetric way of expressing units of water measurement. So, when water is in rest condition or when we are giving water in a field of 1 hectare area, and then certain depth of water is to be given, then it is a, we express in hectare centimeter or hectare meter. So, this is the this can be expressed in a volumetric form. Let us say that when we are telling hectare centimeter, so a volume necessary to cover an area of 1 hectare, or we can say 10,000 square meter up to a depth of 1 centimeter. So, when we say 1 hectare centimeter, this is equivalent to 1 lakh hectare, 1 lakh liters of water. Now, when we say water is in a movement condition, when it is in flowing condition, so this is expressed when it is in a smaller pipeline, when it is in a small channel, we express in a liter per second. So, a continuous flow of water amounting to 1 liter passing through a point at each second. So, this unit is expressed as a liter per second. When the discharge from a canal we are measuring, or discharge from a very big pipeline when we are expressing, this can be in a larger unit, and then this unit is expressed as a cubic meter per second. So, a flow of water equivalent to a stream of 1 meter wide and 1 meter deep flowing at a velocity of 1 meter per second. So, this is this can be expressed as a 1 cubic meter per second. When we say water is flowing, so the water it can be in a open channel, or it can be pipe flow. So, hydraulics of flow through pipe, hydraulics of flow through open channel, slightly it differs. So, when we say the open channel flow, so it defines a passage in which liquid flow with its upper surface exposed to atmosphere. So, top surface of the flowing water is exposed to atmosphere, means it is under atmospheric pressure. The flow is due to gravity. The flow normally it in open channel flow, it is the inertial flow, it caused by the elevation difference, or due to velocity of flow it makes the flow. So, it could be the gravitational flow is dominant, and the flow condition are greatly influenced by the slope of the channel. So, hydraulic grade line coincides with water surface. So, slope of the channel, slope of the water surface, slope of the energy line, they are parallel when we say flow is uniform through open channel. Flow can be uniform or non-uniform, that is one kind of a condition. So, when we say hydraulic grade line coincide with the water surface, this is one of the characteristics of the hydraulics of flow through open channel. Maximum velocity, it occurs at a little distance below the water surface, because at the top of the water surface there is some resistance due to wind. So, that resistance causes reduction in the velocity at the top surface, but slightly below, let us say that about 2 to 3% below the top surface, maximum velocity is attained, and this shape of the velocity profile is dependent on the roughness of the channel, means surface roughness, bottom of the channel as well as the sides of the channel. It affects the velocity profile. So, it influences the slope of the velocity profile. Normally, it is it takes a parabolic shape, and then the other important characteristic which is given by Reynolds number, that means Reynolds number is defined as the inertial force to the viscous force. It is the ratio between the inertial force to the viscous force. Inertial force is due to velocity of flow, and then the viscous force is due to the viscosity of the water or any liquid which is flowing through the channel. So, Reynolds number for laminar flow, it is given as in open channel it is less than 500. For turbulent flow it is greater than 2000 or 2200, and transitional flow, that is between laminar and the turbulent flow, the range is between 500 to 2000, sometime it is also expressed at 2200. Now, pipe flow, when the flow takes place through a pipe. So, pipe is a closed conduit for carrying fluids under pressure. So, flow in a pipe is termed as pipe flow when fluid completely fills the cross section of the pipe and there is no free surface of fluid. Here, as in case of open channel flow, we were seeing that the top surface is exposed to atmosphere. Here free surface it is not exposed to the atmosphere. So, hydraulic grade line not necessarily it will coincide with the water surface. Maximum velocity, it occurs at the center of the pipe, because there is a boundary effect. So, boundary of the pipeline it causes resistance, and so the boundary effect it causes resistance. So, maximum velocity it attains at center of the pipeline. Velocity distribution is symmetrical about the pipe axis, and flow cross section is known and fixed. The Reynolds number in pipe flow 2000 to 2300, the flow is known as a laminar flow. Turbulent flow, when the flow is means Reynolds number is greater than 4000, and critical or transition flow it is between 2300 to 4000. So, this is the transitional flow between this. Now, we will discuss different methods of water measurement in open channel. So, methods which are put up under measurement of flow through open channel, they can be volumetric, means one can have the volumetric measurement or velocity area method, or one can use by putting measuring structures or tracer technique, dilution technique. So, volumetric measurement, it is a very simple thing that suppose a flow is it is a small flow which can be collected in a bucket of known volume, and in a given time the whatever it means the time it fills the bucket or known volume, then one can know what is the discharge through the open channel. So, if it is a small stream, the water can be collected, that one can find out, or from a pipeline also, the discharge from a pipeline it can be calculated by simply measuring the volume of the water filled in the container divided by time required to fill that particular volume. So, this can be given in a liter per second, because such measurements can be done only when the discharge is of a small quantity. Now, area velocity method, or rate of flow passing a point in a pipe or open channel is determined by multiplying the cross sectional area of flow section at right angles to the direction of flow by average velocity of water. So, entire cross section here it is divided into several subsections, and average velocity at each section is determined by using appropriate device. It could be a current meter or it can be a simply float, and this velocity is multiplied with the cross section area of the subsection. So, means velocity is obtained by using current meter or by float method, and then cross section area is multiplied and then one can know the discharge. So, velocity area method, when I was telling that current meter is a device. So, here what we see the this is a current meter, you see in the this part. So, there is a rod which we see here, this is a rod which is mounted, and there is a cable which is suspended. So, when you are suspending it like this, and then the flow which is taking place. So, this the velocity of flow when it is coming in contact with the cups. So, these cups are being rotated by the flow of water. So, this means these cups are this has got a small revolving wheel or vane that is turned by movement of water. So, it may be suspended by a cable. This is what we see, that there is a cable for measurement in a deep stream attached to a rod or in a shallow stream, and then propeller is rotated. This is what we see, this is a these are the cups which I tell that the propeller is rotated by flowing water, and the speed of the propeller is directly related or linearly related with the number of revolution. Speed is directly related with the number of revolutions. So, here is velocity v equal to a n plus b, where a and b are the constants that will depend upon the particular type of calibration parameters of a particular type of current meter, n is the number of revolution. So, number of revolution is basically directly related with the average velocity of the flow. So, corresponding to the number of revolution, the velocity can be obtained from. So, a calibration graph is to be prepared, or a table is made that is supplied by normally manufacturer. So, from the table one can interpolate what is the velocity of flow. Now, here once we are getting the velocity. Now, this velocity is to be multiplied with the area of cross section. Now, so area of cross section, it is the which we are seeing, this is a natural a stream where the bed of the stream which you see, it is not uniform, and so at the corner, means where the depth is shallow, we take measurement at one particular depth. So, at this particular point we are taking the observation by taking the current meter. Then we are dividing the whole width of the channel into number of small strips. So, what we see here, this is the one strip where measurement is being taken. Then another strip is this part, this is your W1 which you see, this is your width, this is your W2, then this is W3 and W4, like this there will be number of verticals, and then the center of these verticals observations are taken, means velocities are taken, and we find out the area under each smaller subsections. So, this is subsection 1, this is subsection 2, like this this is subsection 3. So, like this the discharge is measured. So, each individual subsection will give delta q1. This delta q1 is nothing but the width multiplied by the depth y1 multiplied by v1. So, here delta q1 is delta a1 multiplied by v1 bar. v1 bar is nothing but mean velocity at section 1. So, mean velocity at section 1, like this there will be another v2. So, means measurement, suppose we are taking at two places measurement is taken. So, these two places measurement, that is at point 8 d and point 2 d, and here it is a 0.6 d for shallow depth, and when it is a deeper level, then the measurements will be taken at two places, that is at 0.2 d and 0.8 d, and then we will take. So, v1 bar refers to the average mean velocity. So, this gives a delta q1. So, like this all these data q's will be obtained, and then we will get the discharge of the stream. Measuring structures means quite a good number of structures which are available. One of the structure is weirs. So, what is a weir? Weir is a notch of regular form through which irrigation stream is made to flow, means it passes through the notch. The stream is means made to flow. So, water is passing through a notch, and then weir could be of different shape. It can be rectangular shape, it can be Cipolliti weir. As the name it is given, it is named after a scientist. Cipolliti is an Italian scientist, so it is named after him. It is a trapezoidal weir, and then it could be a V means a V shape or V notch weirs. So, when we are interested or from larger stream, it is made by using a rectangular weir. If it is a medium discharge, means slightly lower discharge, then we use a trapezoidal weir, and V notch is used for smaller the or medium stream size. So, for the discharge from a rectangular weir is given by 0.0184 into LH 3 by 2, LH to the h to the power 3 by 2, where Q is the discharge in liter per second, L is the length of crest. So, length of crest is this is the crest of the weir, this is a crest of the weir. So, this is the length, and then whatever depth of water it is flowing above the weir, this is your h. In this case, this is the h, in this case this is h. So, these rectangular weir, it can be suppressed weir or it can be contracted weir. When I say suppressed weir, means the width of the channel and then the length of the weir crest, they are same. This is what you see here, the water from which the channel it is coming, we are not contracting the stream, but as such in the same width the weir plate is fixed, and then water is made to flow over this, and this is the depth also that. And when the condition it when the width of the flowing stream is large and we are allowing the weir length is smaller, in that case what you see that this is it is brought contracted. So, there is a effect of contraction, and that has to be taken care while we are finding out the discharge from a contracted rectangular contracted weir. If it is contraction is from both ends, so effective this your length is reduced. So, it from both the ends we are giving it L minus 0.2 h into h to the power 3 by 2. That will be the contracted rectangular weir from both the ends. Triangular weir, as the name is said that it is a triangular in shape. So, this kind of a weir, when we say triangular, so this is the shape of the weir, and then this angle it differs. So, a 90° V notch is a commonly used, and this is used for measurement of discharge of a stream of a smaller size, and then this is a empirical Francis formula which has been given, that discharge from a 90° V notch is given by Q equal to 0.013 h to the power 5 by 2. So, like this these discharges it can be obtained. Now, orifice is another device which is used when water is allowed to flow through a circular or a rectangular opening. So, discharge from the from a orifice, an orifice is given by Q equal to pi d square by 4 into C d into root 2 G h. H refers to the head above the head from the center of the orifice, and then the d is the diameter of the orifice opening, d is the diameter of the orifice opening, and so this means your area C d into area of cross section of the flow multiplied by root 2 G h give the discharge from a orifice. Orifice can be used for the open channel flow, this can be used for the pipe flow. Flumes are another devices which are used to measure the flow from open channel, and these are giving better means a precise discharge as compared to, and it does not need the head loss as in it happens in case of wears. So, these are giving reasonably accurate discharge and even in for the partially submerged condition. Now, then now let us come to the flow through pipes and then how the discharge can be measured by using a device which is known as venturimeter. Venturimeter, it is a device which is used to measure the rate of flow of fluid, and it is normally in a pipe system it is fixed permanently, and then any venturi system it consists of a 3 section. One is your the converging section, then there is a throat section and diverging section as the shape it shows. Now, to measure the discharge from a venturi, it uses the principle of Bernoulli equation, that is energy equation. It uses the principle of law of conservation of mass, that is a continuity equation. So, this is a well known Bernoulli equation where you are seeing that there is a pressure head, velocity head and then elevation head. So, as per the Bernoulli principle, this pressure head plus velocity head plus elevation head, this is a constant, but when we are considering two sections, one at the converging section, another one is the throat section. So, these sections are given as a section 1 and section 2. So, accordingly for section 1 and section 2, these P1, V1 and Z1, this refers to section 1, and P2, V2 and Z2, this refers to section 2. Accordingly, if we make it that when the venturimeter is kept at the same elevation, then this equation comes in this form, that V1 is square by 2 g, this velocity head difference equal to pressure head difference, which can be written as the pressure head difference H equal to V2 square minus V1 square by 2 g. So, this is the pressure head difference. Now, this pressure head is used to measure, and that is used in a for finding out the discharge from the pipeline. So, here we are, when we are using energy your continuity equation, that is a Q equal to A1 V1 equal to A2 V2. So, we get the expression in terms of the V1, and then this can be written in terms of velocity head, that is just now which I gave in the previous expression, that is H equal to V2 square. So, we are substituting the value of velocity head, and then we get in terms of A1 square, means this we are getting in this term, and accordingly when we apply, we keep the expression, means substituting the expression of velocity in terms of the area of cross section, because diameters are known to us, we get the discharge from a venturimeter. So, this discharge is to be multiplied with a coefficient of discharge, and then this coefficient of discharge for a particular venturimeter is to be from the calibration one has to get, and then apply here to for finding out the discharge. Now, venturimeter for measuring the what is the head difference, it could be venturimeter can have a heavy liquid or a light liquid. So, depending on the specific gravity of liquid, the value of the means the H can be appropriately changed by using the expression. When there is a heavier liquid, it is used for measurement. When the manometric liquid is lighter than the flowing liquid, that is your water, then in that case the appropriate value of H is to be modified and used it. Pitot tube is another device which is used for measurement of flow through pipeline, and the shape it says that it also uses the concept of the Bernoulli equation. So, the water when it is coming and at this particular point, then the means the velocity head is directly related with the change in the pressure, change in the pressure head, and that causes, means we are measuring the pressure head at this point and pressure head at this point. These two pressures, when it is coming in contact, that causes the rise of water level, liquid level in the pitot tube column, and that is used to find out the how much is the discharge. Water meter, it gives the volumetric value, and these are very commonly used for measurement of the flow through pipeline. So, only thing that the pipe must flow full at all times. So, in all, you might have seen in domestic purpose the volume of water which is coming, and then accordingly the value, the some places the volumetric basis the water the auditing or water charges are made. So, one can know that how much volume of water it has passed through, and these are available in liters, 1000 liters, cubic meter, and where there is a scale is given, counter is made here. So, low pressure pipeline, flow through open channel, open flow meters, these are all available in the market, these are commercially available. Orifice meter, already I have explained you, the orifice meter means there is a orifice plate is inserted into the pipeline, and then the appropriate discharge expression means we will be getting the value of the what is the area of cross section, that is your of the orifice, and then area of cross section of pipe, and then the change in the your value in the pressure head at this point, pressure head at this point. These two values are used to find out H, and then the Q is obtained by using the orifice meter. Propeller meter is another device. These are commercially available for measurement of flow, that is used to at the ends of pipe and conduits flowing full under pressure. So, propeller meters uses multiple blades made up of rubber, plastic or metallic. So, these are this is a propeller, and then it is a more or less same as a water meter. It consists of a propeller mounted in a short section of pipe and geared to a revolution counter, which records the rate of flow and cumulative total. So, in case of water meter, it gives volumetric here it gives in the terms of rate of flow, or also one can know the volumetric measurement also it can be done. So, here in this particular lecture we have discussed what are the devices which are used for measurement of irrigation water through open channel, through closed conduit pipeline, and in all these cases you have seen how the fundamentals of fluid mechanics, that is using the energy equation, a use of law of conservation of, that is a continuity equation. These two principles are in majority of cases it is being used when we are using the flow measurement through in open channels, when we are using flow measurement in pipes, and then the concept of uniform flow is also used in case of open channel flow. Now, in forthcoming lecture, means coming lecture, we will discuss about irrigation efficiency, and you can refer, these are the books which are for this particular topic to read in detail. These are some internet Google search you can have and get more details about the examples, working out the examples also you can read. And so, thank you very much. Good day.